All right, it is 10, so we will get started. And what we're going to start with is looking over our first test. So first, you should be able to now see your answers and also the correct answers, what you got right, what you got wrong. So I'm going to show you how to do that real quick because it's not all that obvious how you get to that. So let me share my internet, my Chrome screen. All right. So right now I'm in student mode. That is, I'm basically looking at Blackboard like a student would. And so what you do is you go to My Grades. And see, I only have one grade, right? I just took the test and I didn't put in any answers. So that's why I only have one grade of thing. So you hit test 1 here and you should see calculated grade. For you, this should be a number at this point. Click on that. Then you will see the questions. You will see the answer that you had. Then you'll see the correct answer and how I scored it. Now, I'm going to go over this briefly, but let me just get a few things out of the way. One, if you question how I graded something, if you want to dispute it all and anything like that, what I ask for you to do is send me an email and we can have that chat one-on-one, either through email or Zoom if you'd like. That's just not something I'd like to do in a whole classroom setting. If it's in one individual person and you're looking at your test and you just have a question how I scored it, that's something that can be handled individually. We don't have to involve everybody in the class in that type of discussion. Two, let me talk about ProctorU here, just basically. So I know there were incidents about people using ProctorU, and I'm not talking about, and I guess I can stop sharing my computer screen for a second here. Okay. And so I'm not talking about academic integrity incidents. I'm talking about like having trouble connecting, taking forever to validate my computer. So I just want to give my rationale for why we're using that system, because I know not every class is using it. Basically, this ProctorU was, the university, the heads of the higher ups in the university, right? They had made a contract with ProctorU, which is they will provide proctoring services for the college free of charge to the students. And I thought that was a great idea because the problem with online classes is that when you take a test, one, I have to have it open note if I don't use a proctoring system. And I guess I'm not all against that. I can make a test open note. It's just going to be harder. Yeah, it's just going to be harder if it's all open note. My big concern is I have no way to validate that you're actually taking the test and not someone else. And I just by a quick Google search, it's easy to find lots of companies, especially nowadays, that will take the test for you. I'm not saying anybody would do that, but that is a concern. So that's why I opted for ProctorU. Now, I will think about how to move forward because honestly, I was answering questions until 11:30 p.m. on Wednesday, which isn't my favorite thing to do in the world when it comes to spending my Wednesday nights. So I will be just evaluating, talking to the head of ProctorU, see, is this going to go any smoother or do I have to find a different way to do this? Secondly, the scores. So the scores on the test, not as great as they should be. I will say, for the first time ever, I've got 2 perfect scores. 2 people got 100%, nailed everything. And I've never had that happened. So congrats. And those of you who got A's and B's, even to the C's to some extent, right? You should feel good. You put in the work, studied hard, and it shows off. So those who didn't do as well as they thought of, I don't want to have a session of me just like beating you up, making you feel bad about yourself, because there's no point in that. What we want to do is we want to learn from this experience about what to expect going in with the test. And like I've said in like the weeks leading up, and hopefully you saw that now, when the questions I ask on the test, 100% come right from what we do in lecture, right? I literally, to make the test, this is what I do. I open up each PowerPoint, and then for some of those questions, I use those and change variables. Some of the questions are copy and paste. Like there are a few multiple choice questions in there that I just said, I'm not going to change like anything and just put them up there. Like about Dalton's law, I think the only thing I change for like the Dalton law question or the atomic theory question is like, instead of like all cobalt atoms are the same, I might have said like all chlorine atoms are the same or something like that. So make sure that you are looking at those. My second point about the test, it is generally agreed upon that for every single hour you have of a science class in college, you should be spending about at least 2 hours studying on your own to get this material. And I said this, I think on Friday last week. If you are just watching me do the problems and not trying the problems, like when I give you that time, if you're not actively trying to do the problems and you're just waiting and you're waiting for me to get the show you the answer, you are not going to learn this, right? The only way you're going to learn this is to struggle and attempt to do it and go as far as you can, get to a point where like you either try something or you have a question and then let me know. Because usually, you know, during these sessions, there's on average 40 of you, and I maybe hear from 3 people throughout the whole session via chat. And if you want to just silently listen, I guess that's okay as long as you're trying the problems. What's even more surprising to me though is from the start of the semester, right now there's about 70 of you. 2 people out of the whole class has asked me for office hours. 2. So if you're not getting this, and if you have a problem and you know you don't know the solution to the problem, I need to know. You need to tell me, we can work on this together. Like, my job is to get you prepared for the test. My job is to get you ready for the test, to learn this stuff. And if you don't tell me you don't know, that you're struggling, that I have this exact question, I can't help you, right? You need to meet me halfway of telling me, I don't know how to do this problem. Can we work on it together? Most of the time it's going to be yes. We also have an SI. You can also help. I did get a message about that where, so SI session was canceled and replaced with a movie night. Yeah, so that was, yeah, I didn't know that was going to happen. Can we use extra credit points for watching that movie? I mean, I guess so that kind of defeats the purpose of the SI, right? The reason I gave extra credit points to go to the SI was for you to go and learn chemistry. So I guess if you can have some kind of, because he didn't record if you watched the movie or not. To me, if you were to ask me, I did have somebody who emailed me that. And my response was, I guess I can give you the points, but in reality, you would get more points studying chemistry for an hour and a half than watching a movie, because I only gave 1% per visit, right? So The maximum you got on your test was like 2% of a boost just for showing up. So if you, sure, I could give you a point for that if you wanted to. But yeah. So we had another session after the movie one though, and we had 3 sessions after you said we could get points. So basically what I did is he showed me anybody who's talked to him throughout the whole semester. And it's kind of funny because you see at the beginning of the semester, there's like nobody. And then at the very end of your test time, that's when you start getting people. Make sure, you know, you are studying on a week-to-week basis. If you're trying to cram all this information in, like a day before the test, the same thing's going to happen where you aren't going to do well. There's too much information in this class to cram. Kind of lost my train of thought there. But what I just want to say is, like I said in the announcements, I will drop your lowest test. So everybody has an off day. We were using a new system. I actually gave a curve for the test because I understand new system, headaches with a new system, online class, not great. So there was a little bit of, I just, you know, gave everybody an extra 3% for online class / using a proctoring system we haven't used. But I want you to ask yourself, you know, if you didn't do well, what could I have done better? The reason I have these reading guides, and I think the main point of college is not to learn a specific subject, although, you know, you talk to students, that's what their main takeaway of college they think is that you should be telling me how to do a job and get these skills. That's part of it, yes. For me, the main takeaway that you can get from college is learn how to be an independent learner. To take any information, any new subject, and after 4 years, get the skills needed to understand that subject, to know what your deficiencies are and when to ask for help. So the reason I have all those study guides and I set it up like I do, that's kind of me forcing you, saying you should probably be reading the book in addition to this. You should be trying to do all these problems in the book in addition to this. You should be doing problems in the back of the book in addition to this, even though I'm not assigning problems in the back of the book, right? So that's my rationale for this. Yeah, 1 sec, let me reply to that. So let me just reply this one message and then we'll go to the test. Okay. Yeah, so test. And when you go through this test, like I said, you will find every single question in there that we asked in class. So physical properties, not much to say there. Odor, taste, and melting point. Acidity and toxicity are not. And again, that's one of the questions I just copy and paste. I did not change a word of that. Let me see here. Definition of a liquid, constant volume. It can change its shape and there are movement of atoms. So a liquid does not change its volume. Water, if I have an amount of water, that amount will be the same unless I like heat it up, and even then it just changes a little bit. How many, so I have 250 milliseconds. How many seconds are that? So 250 milliseconds. There are 1,000 milliseconds in 1 second. That's 0.250 seconds. So 0.250. And I did try to stress that you need to know these. So I asked you questions directly related to the metric system. So that's 0.250. How many, so I have 1.25 kilograms. How many grams is that? So I have 1.25 kilograms. For every 1 kilogram, there's 1,000 grams. That's 1250 grams. So that's 1250. Next is our density question. So I have 2.3 grams of paint. There's the density of paint. How many milliliters of paint do I have? So this is another unit conversion. So I have 2.32 grams of paint. For every 10.27 grams, I have 1 milliliter of paint. So that's what density means. Grams cancel out. Multiply 2.32 by 1, divide by our density, and you get a number in milliliters. Everybody had like a different number for this. There was 40 different possibilities. So your numbers aren't going to look the same as my numbers, but it's the same problem. Right? So here's Dalton's atomic theory, again, copied and pasted right from our slides. The only thing I did was change some of the element names. But like we said in class, Dalton's atomic theory states, elements combine in whole number ratios and all oxygen atoms are identical. So not that carbon and hydrogen have the same mass and you cannot convert one element to another. So that is alchemy. Alchemy is not real. All right, so this question 7, that seemed to get people fits. So using isotope notation XA, do carbon with 6 neutrons. Well, carbon has 6 protons. We know that from the periodic table. If we have 6 protons plus 6 neutrons, that's C12. 8, here's another isotope. Give me protons and neutrons. Bottom number is protons, top number is mass. So you take your mass minus your protons to get 60 neutrons. So that one's 5660. Okay. And the next 2, I was a little bit surprised how poorly we did as a class, because I thought these were more or less easy points. Most of them. S, tell me the charge of the ion formed by this element. So it is in column 16. It is right below oxygen. These 2 molecules, for the most part, will always be -2. Okay. If you're -2, you are an anion. One sec. Somebody is talking over me.
But then they'll see it and or you keep on.
FYI, Brianna, everyone can hear you.
Let me see them.
There you go. Yeah, so should be muted again. So, and let me just say, I hope you're paying attention while I do these lectures. I know it's easy not to because you're at home, but you know, that's why we're doing these. So sulfur is right below oxygen, -2. If you're minus, you're an anion. Anion stands for a negative ion. And anything to the right are nonmetals. Mg is in the second column. Anything in the second column is +2. Anything on the left is a metal. And metals, since they're positive, they're cations, because cations are positive or positive. That's how I remember that. Okay. Will we see these problems again on future tests? You will see these on the final exam. You will see skills. The skills we use on test 1 will be skills we use again. For example, how to find molar mass, how to know what a metal and a nonmetal is, how to know if something's a cation or an anion, but I won't ask specific questions. You'll just need to know that knowledge to answer future questions, because chemistry is building on itself. Well, we have access to our tests. Yes. If you missed the beginning of lecture, rewatch the recording. I show you how to get that. Okay. 1 sec. Let me reply to that. Okay. So 11, this was a giant unit conversion. So I have 78.67 grams for every 168.72 grams. I have 1 mole. I want to get to atoms. That's Avogadro's number. Multiply across, divided by 168, and you get a giant number. 12 isotopes. So this was one of the equations I gave you on the equation sheet, right? So isotope number 1 has a weight multiplied by abundance, so 0.34, plus isotope number 2, weight multiplied by abundance, plus isotope number 3 multiplied by abundance. Do those 3 problems, add them all up together, and you get the molecular mass. Can you explain for the answer for 11? I don't get the percentage from the answer. The percentage is just saying the tolerance level when this program grades. For this question, it didn't work so well, but this is just saying that plus or minus 0.5%. If a student puts in an answer that's plus or minus 0.5% of the real answer, it will count it as correct. This is a way to, if you did the right math, but let's say you dropped a sig fig that you weren't supposed to, or your answer is just a little bit off, but obviously the only way you could have got that answer is by doing the correct conversions. I want to give you credit for that without me having to verify every single answer. So I put in these tolerances to say if you're just 0.5% off either way, you get the right answer. That's what that means. For number 11, yeah, so those of you put it in scientific notation, you got the right answer. For some reason, it's not displaying it in scientific notation, and that was actually a big problem for the system, and that it couldn't read scientific notation when you all put it in. So I graded question 11 manually. When I was going through everybody's test, I noticed that was happening. So if you put in scientific notation, you got it right. You got all points. So that was taken care of by me. Okay. Question 13, how many sig figs does this answer have? All right, so first thing you need to do is you need to do parentheses first. Line it all up. So we're doing addition and subtraction. We have 1 number after the decimal. So when we do this, we should only have 1 number after the decimal. And this answer is like 99 something. I forget what the exact number is, but it's like 99.8 or something like that. I'll actually do the calculator because I know I get in trouble if I say it should be something like this. Let me actually give you the real answer for that. Okay, so we have 544.621 minus 444.9. So 99.7. So it should be 99.7. You take 99.7, multiply it by 54.400, and you see this number has 3 sig figs. This number has 5 sig figs. So we're going by the multiplication rule now, where I only pick the thing with the smallest amount of sig figs. That's why the answer is 3, right? So the answer is 3 sig figs. Questions 14 and more or less onwards are more naming questions and periodic table questions. So PCl3 is made out of nonmetals, so it's molecular. CCl4 made out of nonmetals, so it's molecular. NiCl2, metal, non-metal, so it is not molecular, that's ionic, so false. CO2, all molecular, now 18. N3Cl6, that's a molecular compound. For molecular compounds, we give it the nomenclature of trinitrogen hexachloride. While NiCl, that's an ionic compound because you have a metal plus a non-metal. Nickel is a transition metal. It is not in column 1 or column 2. Since it's a transition metal, we have to give it a Roman numeral, and that's nickel 1 chloride. Nickel 1 chloride, make sure to go back to the lectures before the final exam to understand that one. H2PO4. PO4 is it's a polyatomic, or polyanion rather, so it's a polyanion. Polyanions all get special names when we come to acids. So we don't have any hydrogens for this. This is just phosphoric acid. I think phosphoric acid was actually one of the examples we went over class too for our naming of the acids. Molecular weight. Most people got this one right. So you just look up nitrogen in the periodic table, that's 14.007, plus oxygen is 16 times 2, because we have 2 of those are 46. Lastly, we have our balance equation. So I'll just do this real quick. So we have hydrogen, sulfur, oxygen, iodide on each side. We start with, let's see, 3 on the left and 4 on the right. Sulfur, 1, 1. So I'm not going to try and touch sulfur. Oxygen, 4 on the left, 1 on the right. Iodide, we have 1 and we have 2 there. All right, so there's a lot of different ways we can do this. Each way, what you decide to balance first really doesn't matter. But let's just say if we wanted to balance the oxygens first, you put a 4 there, right? So that becomes 4 oxygens and 8 hydrogens, or sorry, 10 hydrogens. Okay, so I have 10 hydrogens on the right. I have 7 on the left, or 3 on the left. My oxygens are balanced out. So if I put an 8 there, I go to 10 hydrogens, and I go to 8 iodides, and so you put a 4 right there. Or sorry, you go to 8. So that is our balance equation. 1, 8, 1, 4, 4. So for the balancing equations, this is okay if you didn't put the subscripts the way you did. I couldn't figure it out and just put them regularly. Yeah. I did not. I would never take off points if you put the subscripts as like H2SO4 and you didn't make them small. I do not care about that. So yeah, don't ever worry about doing that on a test. I will always correct that for you. What I will say about balancing equations, I saw so many people do something like H2O4. You can never, ever, ever change the number, the subscript. You can't do that because you're saying I have created a new molecule. You can only change the numbers in front. All right, so there's the test. Like I said, your test is available to you. Just go on Blackboard. If you missed the beginning of the lecture, look at the recording and we'll show you how to do that if you're not sure. Otherwise, we will move on to our actual lecture today, where we will be talking about solutions. So let me share that. Let me just make sure it's the right one. Okay. So GC 921. So even though it says Monday, September 21st, we didn't actually get to this Monday. So that's what we're going to be covering today. So we're talking about solutions now. We're going into solution chemistry at this point. And when you talk about solutions, one way we can describe them is either by saying they're dilute or concentrated, right? So a dilute solution has a little solute, while a concentrated solution has a lot of solute. And the thing is, there's like no cutoff point where you say this is dilute versus this is concentration. This is just more of a descriptor that you just learn the meanings after dealing with it a lot. So there's no number I can tell you where something goes from dilute to concentrated. It's just a descriptor and saying there's a lot of stuff in here, so it's concentrated. The better way to talk about something is called molarity. Okay. Now, molarity is not the same thing as moles, right? So don't get those two confused. They're similar though. And our symbol for molarity is big M. Now, anytime in chemistry, if you see a number followed by big M means molarity, right? And what molarity stands for is the number of moles of your solute divided by the volume of your solution, and this is always in liters. So it's always moles divided by liters. Molarity is moles divided by liters. Some more terms. Solute is the minor part. Solvent is the major part. So usually water is our solvent. When you combine a solute plus a solvent, you get a solution, right? So that's our terminology. Solute, minor part, solvent, large part. Together, they make a solution. So here are some questions to test ourselves to see if we understand this concept of molarity. I will do 1A, and then I want you to do B, C, and D. If you want to check if you got B, C, and D right, please let me know. If you have questions about B, C, and D, let me know. If you don't want to know, let other people know you have questions, send me a private message, and then only I will see it. And as always, I won't mention people's names in a private message. Okay, so I have 32 grams of carbon dioxide, and it's in 1.25 liters of solution. What is my molarity? All right, so molarity, as we see up here, is moles divided by liters. Okay, so I need moles. Right now I'm in grams. So we go to our periodic table and we find the molar mass of carbon dioxide. So this is what I was talking about, where I'm never going to ask you a question of like, what's the molar weight of something, but we will use it in problems moving forward. Okay, so CO2, the weight of carbon is 12.011 plus oxygen is 16, and we have 2 of those. So the weight of carbon dioxide is 44.011 grams per mole. Okay, so my first thing I need to do is convert 32 grams into moles. So 32.0 grams of carbon dioxide. I have 44.011 grams for every 1 mole. Grams cancel out, and I calculate moles. So I have 0.727 moles of carbon dioxide. Once I have moles, you just divide it by how many liters of solution you have. That's 1.25 liters. And your molarity is 0.5 0.82, and you put a big M for molarity. So my solution is 0.582, has a molarity of 0.582. And that's the answer. So see if we can do B, C, and D. Yeah, so question, can substances that are not aqueous be a solvent? Yes. Aqueous means more or less water. So in organic chemistry, they have a lot of things that are not water. For example, if you want to take gasoline, gasoline is not aqueous, but if you dissolve like fat in gasoline, which you can, fat's like nonpolar, some fats are, the solvent would be gasoline. The solute would be your lipid molecules or fat, and that would make a solution. So yes, very much can. It doesn't have to be water. It's anything in a solution, the majority part. Again, if you have questions, if you have answers, let me know. Do be trying to do this. If right now, like I said, if you're just waiting for me to do this, the only way you can learn how to do chemistry is to actually try it. And that's actually true about, everything. So B, would we change 230 ml to liters? 230 ml. That's for C, but yes. When doing molarity, you need to be in liters. 0.0128. So let's look at B here. So I have 1.23 moles. I have 123 milliliters. So molarity is moles divided by liters. So the first thing I need to do is convert milliliters to liters. So milliliters cancel. I'm left with 0.123 liters, right? So now I have moles and I have liters. So take 1.23 moles divided by 0.123 liters. 10. So when do we round the number? Is it only for the final answer? Generally, yeah, you round at the very last step. For A, I did my rounding in the problem, which isn't great. But if you have a calculator, you want to round at the very end. Yes. So I did have a question here about like, do we convert like our volume into a weight? And you never want to do that. Leave your volume as a volume. In our final answer, would you take off points if we only said 10 molar instead of 10 molar of C6H6? No, I will not take off points for that. I would take off points if you just said 10. You need to say molar. You don't need to say molar of C6H6 though. C, I have 1.23 moles of sodium chloride. How many moles are in 230 milliliters? So I have 1.23 moles for every 1 liter, right? Now I have 230 milliliters, but my molarity is in liters. So I need to convert one of these two numbers. So let's convert milliliters. And I say that because I cannot multiply a liter by a milliliter. When I'm working with volumes, my volume has to be the same unit. So 230 milliliters. For every 1,000 milliliters, there's 1 liter, which is 0.230 liters, right? So now I have how many moles are in 0.230 liters. And I have my molarity, moles divided by liters. And if I multiply that number by a liter, I'm left in an answer in moles. That's why I love the train track so much, right? Because it'll tell you just by looking at your units, do you multiply or do you divide? It works every single time. It will never fail you. So if you do that, 1.23 multiplied by 0.230, that should be 0.283 moles. So can we put 10 molar instead of 10.0? That would actually be wrong. In that you would get marked wrong for sig figs because we have a number of 3 sig figs divided by another number of 3 sig figs. Your answer should be 3 sig figs. That's why I put 10.0 and not 10. So you would get marked off a little bit, not a lot, because my main focus is, can you do the problem to begin with? But like maybe outside of like 100% of that question, you might get like a 95% of that question. Okay, last, I have 3 moles of NaCl. How many liters do I dissolve this in to have a solution that's 0.859? Well, I have 3 moles divided by X number of liters. That equals 0.859 moles per liter, right? So I'm doing algebra. I need to solve for X. So for algebra, multiply each side by X. You get 3 equals 0.859X. Divide each side by 0.859 to get your X alone. And X should be 3.49 liters. So those are problems dealing with molarity, and really these questions are just to hammer home what does molarity mean. Molarity is moles divided by liters. So any questions about that? It's exam 2 starting with this slide. No, exam 2 starts what? Friday's lecture? last Fridays. And if you're ever wondering what slides are in the exam, go to Blackboard. And if you go to test 2 questions, those are everything we cover on the exam. D, I got 2.577. So the number has to be bigger than 3. So let me just do my calculations here. So 3 divided by 3.49. Yeah. No, it's definitely 3.49. So I'm not sure how you got 2.577. Remember, it's 3 divided by 0.859. You could have done 3 multiplied by 0.859 and got that. Would 3.50 be correct? I probably wouldn't mark that wrong in all honesty, but 3.49 is the correct answer because the whole answer is 3.492, and so you'd round down to 3.49. All right. Now, the next thing we're going to look at, and probably the last thing for today, is the dilution equation. This equation will tell you how to make diluted equations. And remember, diluted, if you dilute something, you just make it a lot less concentrated. There's actually fake medicine derived around this called homeopathy, where you take like an ingredient and then you dilute it, and that's supposed to make it more potent. That's not how the world works. But that's what a dilution is, where you take a substance and you just make it less concentrated. And we can do that. We can find out those calculations by M1V1 equals M2V2. Where if you have 2 solutions, if you have like a solution and you take a portion of that solution and then you add more water, you can figure out what the molarity of your new solution is. And it's molarity of solution 1, that's what the 1 stands for, multiplied by the volume you took from solution 1, so that's V1. That will give you the new molarity of solution 2 when multiplied by whatever the final volume of solution 2 is. So M1V1 equals M2V2 is how we decide, how we figure out when we dilute something, what is the new concentrations. So I will do A, and then we'll leave it off with being C. For this, I like to draw pictures myself. So I have a solution in A that's 1.20 molar. So I'm just going to call that M1. That's my first solution I encountered, so I'm going to call that M1. I take 30 mils of this. So that's my first volume. I take 30 milliliters of my solution. And what I'm going to do is I'm going to take that 30 mils, so that's V2. I'm going to take that 30 mils, I'm going to add it to 70 and get 100 mils. And the question is, what is my new molarity? So when working on problems with a lot of numbers like that and variables, I find it so helpful just to the side or wherever, write down what our variables are and assign them. So I assign M1, V1, and V2. I'm trying to figure out M2. So our equation is M1, V1 equals M2, V2, right? So 120, that's M1, multiplied by volume, 30, equals M2, I don't know, that's what I'm trying to figure out, multiplied by 100. So it's simply 1.20 multiplied by 30 divided by 100, and M2 equals 0.36 molar. All right, so we have Well, we're right out of time. So if you need to go, please feel free to log off. I'll probably just stick around for a couple more minutes and hammer out B and C. So if you need to go, just make sure you catch like the extra, the last few minutes on YouTube here. But see if you can at least figure out B, right? See if you can follow what I just did and apply it to B. Where did the 100 come from? Okay, so if we look at the problem, I said I took 30 mils of my solution and mixed it with a 70 mils. So I'm stating in the problem, I'm making a new solution where I combine 30 mils of one solution plus 70 mils of another solution. So in total, my solution is 100 milliliters. So in total, I have a solution that's 100 milliliters. Do we have to change the liters or we can leave it as mLs? You do not have to change the liters. The only thing you have to worry about is big M of M1 and M2, are they the same units? So they have to be the same units. Are V1 and V2 the same units? They have to be the same units. It doesn't matter if it's milliliters, liters. It doesn't matter if it's millimolars or molars. All that matters are that both volumes have the same units, both molarities have the same units, and the math will work out. So let's do B here because I am technically out of time. So anybody who just messaged me, unfortunately, that is not the right answer. Thank you for trying. I appreciate it, but not quite. So let's see how we do this. So I have a solution. It's 1.20 molar. I'm going to call that my M1. Now I want to make another solution. That other solution has a molarity of 0.75 and a volume of 500. And the question is, how much of my original NaL solution do I need to take to make a new solution that has these components? So I have an M1, I have an M2, I have a V2, but I don't have a V1. So let's solve this. So M1 is 1.20, V1 unknown, M2 would be 0.75, V2 is a 500. So solve for V1, and you should get a total answer of 312.5. Sig figs, though, should be 3.1 times 10 to the 2 ml. So 312.5. So I'm not going to do C just for time's sakes, but the answer key will be posted up when we finish this lecture. But are there any questions about how I did this? It seems to be a little bit confusion, at least from the problems or the answers I was seeing there. So what were you confused on that I did, I guess is a better way to put it. Do you have any questions what I did? Do you have to put it in scientific notation? For B, you do, because there's only 2 sig figs, and that's the only way to express it with 2 sig figs. Like if you did 3100 or something like that, that's not 2 sig figs. So the only way to express this number with 2 sig figs is scientific notation. For B, I put them in the wrong order. Yeah, so the hardest part of these questions is simply figuring out what M1 V1 and M2 V2 are. So you want to read the questions very carefully, right? I have a 1.20 molar solution of NCl. This is my molarity. I want to make. So the word like I want to make is saying I want to create a new solution. That's kind of your key there. And I want the solution to be 500 mils. Since we're talking about a different solution, I cannot call this M1 because M1 and I can't call it V1. M1 and V1 refer to one solution. M2, V2 refer to a second solution. So if I want to make a new solution that's 500 mils, it is not V1. It is a second solution, V2. And this new solution has the molarity of 0.750 M2. So that will come with looking at these problems more, how to tease out exactly what goes with which variable goes to either M1 or V1. That being said, for those of you who are still here, sorry again for taking so long. I just want to say one more thing and then I'll let you go. If you ever want more example problems, let me know. There are literally hundreds on the internet, and I will go and I'll find problems that I look at and I say, oh, these are good to give as example problems. So if you ever want example problems, feel free to email me. If you're doing example problems, there's more in the back of the book too. If you're ever wondering if you did something right, you can email me and I will check your work and I'll tell you if you're right or not. Okay, if you could email me to remind me, because I have to actually run somewhere right now, and so I might forget. So anyone who wants example problems for any topic, please do email me. Look in the back of the book. There are those there. If you tell me via chat that you want more, I might forget. So if it's email though, it's right there in front of my face. It should be 312.52. Think that's right. Anyways, I have run super late, so sorry for anybody for keeping you. But that's it for today. We will pick up on solutions on Monday. I will post a homework like always. Make sure you do that. Otherwise, I will see you later.